class, we'll just complete the exercise 5.4, which is based on the exponential functions. Okay. So exercise is like differentiate the following with respect to x. So in that first one is e power x over sin x. So now I'll just go with the quotient rule. That's nothing but a numerator is also with the one complete function, that is the exponential, and the denominator is with a trigonometric function. So I can go with a quotient rule. So which is, so as we know that d by dx of u divided by v. U is a one complete function, v is another different function. So in that case, what we will do is denominator square is nothing but v square, and we need to write the denominator function as it is, and we need to differentiate numerator, that is the u. So in between we should use minus. Then write the first function is nothing but a numerator function as it is. Differentiate the denominator next. So this is what the quotient rule. So this rule we are going to apply for the given problem, that is e power x upon sin x. So derivative of that, d by dx of e power x divided by sin x. So I will just go with the same rule, that is the quotient rule. So denominator is the sin, therefore sin x all square, or you can write it is the sin square x also. Okay, write the sin x as it is. Now the derivative of the numerator is nothing but, I just write it in a standard way, d of e power x. D stands for derivative, minus, write the numerator e power x as it is, e power x. Then you need to differentiate the denominator, therefore d of sin x. Clear? Now we can write this as sin x, e power x derivative is e power x only, minus e power x, sin x derivative is cos x. All things divided by, we can write it as sin square x. Or you can write in both the term e power x is there, which is a common, hence I can take e power x is a common, remaining is sin x minus cos x over sin square x. So this is what the derivative of a given problem, that is e power x divided by sin x. Hope you guys understood. So when we are going to apply the quotient rule is nothing but numerator and denominator are two different functions. Then you can apply the quotient rule. Is it clear? So second one is e power sin inverse x. So as I said that the derivative of exponential function is nothing but derivative of e power some function. You need to write the function as it is. Again you need to differentiate the power of e. Is it clear? So now derivative of e power sin inverse of x, we can write it as, write the exponential function, whatever the function, you just write as it is, that is e power sin inverse of x. Again you need to differentiate this power of e. So it's nothing but sin inverse is there. Hence we can write e power sin inverse of x. Again sin inverse derivative is, as we know that 1 divided by square root of 1 minus x square. Or we can write this as e power sin inverse of x, all thing divided by square root of 1 minus x square. This is what the derivative. Clear? Okay. Third one is e power x cube. E power x cube is nothing but, I write it directly, is nothing but the derivative of this exponential is nothing but, write the exponential function as it is. Again differentiate the power of this e, is nothing but x cube derivative. Okay, so I'll write it the given function exponential function as it is. Next is, you need to differentiate the power of a e is nothing but x cube. Okay, e power x cube. The derivative of a x cube is nothing but 3x square. Why? Because the power of this x will come to as a product and the power of that will be decreases. So with the help of the formula, that is a derivative of x power n is nothing but n into x power n minus 1. Hope you guys understood this. Therefore, derivative of e power x cube is nothing but e power x cube into 3x square. So fourth one is sine of tan inverse of e power minus x. Now we can consider this is a composite function. Is it clear? This is a sine, yes, of course, but sine, for this function we don't have a variable. So instead of a variable we have a function, right? You can consider this is the inner function. So now it is a combination of three different functions. One is a trigonometric, another one is a inverse trigonometric, and one more is a exponential. So in that case, you can consider this is a composite, and as you guys know that how to differentiate the composite. It's nothing but derivative of a sine. First you have to do it. So sine derivative is a cos. For this function you need to write the variable is nothing but the inner function. All thing you have to write. That is the tan inverse of e power minus x. Next what you do, you need to differentiate this inner function, that is tan inverse of e power minus x. Is it clear? So now the cos of tan inverse of e power minus x. Again, tan inverse of x is not there. It is again a one more function. Tan inverse derivative is 1 divided by 1 plus x square. Instead of a x, we have an exponential function. Therefore, 1 divided by 1 plus, instead of a x, we have an exponential, and it is e power minus x all square. This is the derivative of a tan inverse. Instead of a x, again the function is there. So, you need to differentiate again exponential function. Hope this is clear. So now this is cos of tan inverse of e power minus x into 1 divided by 1 plus e power minus 2x. You can multiply these two, the power of exponential. And the derivative of e power minus x is, I'll just write it directly, that is minus e power minus x. Hope you guys understood why it is minus e power minus x. Exponential derivative is as it is the same function. Again you have to differentiate the power of a e. Power of a e, we have a x along with a negative sign. Derivative of a x is a 1, but negative is there, hence you will get the minus 1. Okay. Therefore, so derivative of a given composite function is nothing but, I'll write the negative sign first. That is minus cos of tan inverse of e power minus x into e power minus x whole thing divided by 1 plus e power minus 2x. This is what the derivative of a given composite function. Okay. Fifth one is log of cos of e power x. Log of cos of e power x. Again it is a composite. Clear? So log is a one function, cos is a trigonometric, exponential. Three functions is there. It is a combination of three different functions. Hence you can consider this is a composite function. So differentiate same as the previous one. Differentiate first log. Log derivative is 1 over x. Instead of a x, cos e power x is there. Therefore, a derivative of log x is nothing but 1 over x. So instead of x, here is a cos e power x. Therefore, the derivative of log will be 1 over cos cos is nothing but trigonometric ratios, that is the tan. So here the variable is the same. Okay. So sin e power x divided by cos e power x is minus. I can write that is the tan e power x into e power x. So if it is a confusion, just write the e power x first. Okay. Or we can write minus e power x into tan e power x. This is what the derivative of the given composite function. Clear? So this is what the fifth one. Sixth one is 6 terms is there, and it is the sum of the exponential term. So derivative of sum of the terms, we can differentiate it separately. So it's nothing but, I write it directly, that is a derivative. I just represent that in a caps D, or you can write it, this D is nothing but d by dx. Instead of writing d by dx, I just write it directly, that is a caps D. Okay. So e power x plus d of e power x square plus d of e power x cube plus d of e power x power 4 plus e power x power 5. So sum of the term is there. It is till x power 5. It is the increasing of the power of x is there. So total there are 6 terms. Is it right? Yeah, 5 terms. So derivative of e power x is this e power x only. Derivative of e power x square is nothing but e power x square. Again you need to differentiate x square is nothing but 2x. Okay. So e power x cube is e power x cube only. X cube derivative is 3x square. Hope you guys are getting this point. And e power x power 4 into 4x cube. And the last is e power x power 5 into 5x power 4. Okay. In a simple way, I can write this as, or else e power x plus, I just write the polynomial first, that is 2x into e power x square plus 3x square into e power x cube plus 4x cube into e power x power 4 plus 5x power 4 into e power x power 5. So this is what the derivative of the given sum of the exponential terms. Okay. So seventh one is square root of e power root x. Okay. Just listen this one carefully. So as we know, the derivative of root x is nothing but 1 divided by 2 root x. Hope you guys are getting this. So root of exponential, again the power root x is there. Okay. You need to differentiate this carefully. So root x is nothing but 1 divided by 2 root x is there. So root of x is nothing but this inner function. Clear? So inner function is nothing but e root x is there. Okay. Within this, inner function is like, again you have one more different function. It is nothing but exponential function. In that case, you need to differentiate again, right? So it is nothing but derivative of e power root x. Don't mess up with the concept. So 1 divided by 2 times root of e power root x. Now the derivative of exponential is nothing but the exponential function only if the power of a e is a different term. instead of a x, if it is a x square or a root x or a log x like that, in that case you need to differentiate this power of a e again. Therefore, the derivative of root x it is. So 1 divided by 2 into root of e power root x into e power root x. So root x is 1 divided by 2 root x. Okay. So now we can write e power root x whole thing divided by 2 into 2 constant, that is 4. Again it is both the term it is with the square root. So I will just write it within one square root. These two terms is nothing but x into e power root x. Oh, this is understood? Bit confusing. Okay, I'll just explain again. Root of e power root x is there. You can consider this is a one composite function. Why? Because root of x means you can write it directly with the help of the derivative of root x. So here it is exponential is there. Again the power of exponential is a one more derivative term. So in that case you can consider this as a composite function. Now root x derivative is 1 over 2 root x. 1 over 2 root x is nothing but this inner function. Therefore root e power root x into derivative of this inner function e power root x. Okay. Just write this term as it is. E power x derivative is e power x only. Instead of a x, if any other different term, you need to differentiate again. Is it clear? So instead of x, here we have a root x again. So in that case, we have to differentiate that root x again. Therefore, e power root x divided by 1 over 2 root x. So I just write it in a simple way. That is e power root x. That is only a one numerator term. Writing that divided by 2 into 2 is a 4. So here both the term it is with the square root. So we just write it the square root only a once. Within that we just write these two terms in a product form. Okay. That is x into e power root x. Hope you guys understood this. Okay. So I'll just do the last one. 8th one. Remaining two problems. That is the simple problems. You guys do it. 8th one is the log of log x. Nice one. So log of log x. Two same function, but it is a combination of two functions, I can say that. So you can consider this is a composite function. So in that case, what do you do? Differentiate this function. So derivative of this, you have to write it. Along with the variable, you have to consider this inner